Hey everyone. Welcome to one of the final few recordings we're gonna have for our 302. Today, I decided because last class you guys mentioned that you really wanted me to do some of the exams. So I'm not again. I tried my best, right? And as I mentioned before, I was trying my best to do the exams, and I have some time now. It's almost midnight right now. It's midnight, but I'll try to make it short and simple for you guys to watch. I am gonna go over exam 21, as we did 22 in class, so we're gonna do 21 over this video, and that will leave you with one more exam 20. Again, no promises, but I try my very best to do it over the weekend. If I have any time in between my projects or my classes, I'll try my best to do it. Okay. Um, but no promises for now. So the same style, the same thing we're gonna apply. I'm gonna share from my iPad here, and you guys can watch me go through one by one. So I am gonna share my screen here. Okay, why is it doing like that? Portrait mode. Okay, whatever. Okay, cool. So I printed the exam here so that it's easy instead of me going through and writing the questions one by one. But this is the exam, simple enough. I think 4 or 5 questions. Sorry, 4 or 5 questions, not very difficult. I looked at them. I think 2020, wait, 22 or 2022 is the hardest exam out of the three. So let's start with this, okay? So this one is very simple. Um, this one is simply saying use mesh current method, write three independent equation in terms of mesh current in A1 I1, A2 I2, A3 I3 equal to A4. Okay. So this is my I1. So first of all, what do you notice here? I noticed that I3 minus this one here, right? I3 minus what is this? Is this I2? I2 is equal to 2IY, right? That is the first thing I noticed. Second thing I notice is where is my IX? What is IX? IX is equal to I3, correct? I think those are the very few things that we notice first. First, this is IX, same direction as I3, so that's why this happened here. This one is 2IY, it's going up, so it's following the direction of I3, and that's why it's I3 minus I2, okay? So let's do our normal KVL, normal mesh on I1, because that's the first equation they're asking for. So what do you get? You get negative 4IX plus 10 times I1 minus I3. Let me rewrite this. I3 plus, plus 5 times IY, which is also I1 minus I2. Oh yeah, one more thing. What is IY? IY is I1 minus I2, right? Okay. So 5 I1 minus I2. What are we? That's it, right? Equal to 0. So you know IX is I3, so we can substitute this with I3, and that's basically it. You just need to solve what do you have here, and solve for A1, which is the coefficient of I1, solve for A2, A3, and find A4. I'm gonna do it for one, and you guys will do for the rest, okay? So this is minus 4I3 plus 10I1 minus 10I3 plus 5I1 minus 5I2 equal to 0. So I have 5I1, I have 10I1, so that's 15I1 plus I have, or minus 5I2, because that's the only I2 coefficient I have, plus, or minus, I guess, minus 14I3 is equal to 0. So what is coefficient of A1 is 15, what is coefficient of A2 is negative 5. whereas coefficient of A3 is negative 14, coefficient of A4 is 0. And why would you say negative? Because as you can see here, the formula says that there is a plus in between them. So A2 and A3 are the negative factors. So again, I'm not going to simplify all of them. I'm just going to give you the equations or how I derive the equations, and then you guys can probably be able to do the rest, okay? Just algebra stuff. So second mesh, which is I2. Okay, so what do you see here? Well, what is this current here? This is 19 amp, right? We know this current here going this way is 19 amps. Okay. So the equation we have is gonna be 5 times I2 minus I3 plus, actually, no. This is gonna require a little bit of a super mesh, right? Because this, you can't really go through this here. So we're gonna do some sort of a super mesh, okay? So let's start from the 5 again. 5 I2 minus I1 plus 10 times I3. Remember, everything we want needs to be in terms of I1, I2, I3, because this is where the formula looks like. So 10 I3 minus I1 minus 240 plus 40 times I1 minus 19. I1, sorry, I2 minus 90. This is I2 here. This is I2. This is very small, but this is, my direction is going through here. So it's I2 minus the current going the other direction was 19, equal to 0. So, you know, you're gonna move things around. You have everything in terms of I1, I2, I3. I think this is very simple to do from here on. Third equation, very similar stuff, where is I3. So this is gonna be what? 10. I'm gonna write it up here, 10 I3 minus I1 minus 240 minus 240. Oh, actually this is also gonna require some sort of a super mesh, right? Okay. So from here, this one, we can use this equation here, right? Because what is this equation? It's I3 minus I2 equal to 2IY. That's what we have. What is IY? IY is I1 minus I2. So I3 minus I2 is equal to 2 times I1 minus I2, right? And then, yeah, that's basically it. So I3 minus I2 minus 2I1 plus 2I2 equal to 0. So you have negative 2I1 here. And this is negative I2 plus I3 is equal to 0. Correct? Wait, let me double check this is correct. Yeah, that's it, right? Yeah, that's, I think that's all you need, right? Mhm. So this is your answer here. Well, you would say this is different than the answer sheet because I have the answer sheets in front of me. But if you multiply negative on both sides, you end up with 2I1 minus plus I2 minus I3. Oh, wait. This is not the same answer. Wait. What are we doing wrong then? A negative, this is I3 minus I2 is equal to 2IY. IY is I1 minus I2, that is correct. So I3 minus I2 minus 2I1 plus 2I2. Okay, so what happened? What did I do wrong? So this one is negative 2I1, negative 2I1 plus I2, plus I2 plus I3. Yeah, sorry. Now multiply negative by both sides, 2I1 minus I2 minus I3 equal to 0. Same answer if you multiply negative both sides. Okay, looking at this question now. This is a Thevenin equivalent, so it's not very difficult again. This one is just asking for the voltage across here, or V Thevenin, which is, again, you cut the load, right? And you find VOC, or V Thevenin, whatever you want to call it. It's very simple here, right? Because this depends on Vx. So we kind of have to find some sort of an equation to do Vx, okay? Sure. First, what is, I guess, we can do, if we want to find the voltage here, right? Let's call it Vy. What is Vy? Vy is here, across this one. We can do some sort of a voltage division, right? So Vy is called, Vy is gonna be 16 times 3 divided by the sum of the two resistors, so 5 plus 3. You end up with, what is it? 1642, wait, 32 plus 16, that's 48. 48 divided by 8, right? Which is 6 volt. So we found the voltage here at 6 volt. And then basically what happens is you can do some sort of uh, I will tell you why we got this here, but the idea is let's do a big KVL here. So negative 16 plus 5i plus Vx plus 4i. Let's call this one I1 and let's call this one I2. Actually, wait. Before we do a big KVL that encompasses everything here, what happens is, let's think about this question, sorry. Vy, Vx, I want to figure out my current here. Let me figure out my current here first. Negative 16 plus 5i plus 3i is equal to 0. What is this? 8i is equal to 16. I is equal to 2 amps, right? So this is 2 amps going through. Okay. Now, wait. Yeah, so let's now do the big KVL. Negative 16 plus 5 times the 2 plus Vx plus V over the 4 plus VOC is equal to 0. Correct? Well, you know this is cut, right? So what does that mean? It means there is no current going through here, right? If that means no current going through here, that means this is a short, right? As we mentioned. So that means this is out, the V4. Okay. What does that mean? If this is short, we know the current is 0. Current is 0, which means this current is also 0, which means 2Vx is equal to 0, which also means Vx is 0. So we cancel Vx. So basically VOC is equal to 16 minus 10. VOC is 6 volt. Again, open, no current. If this is no current, this is the opposite of this current, which means it's also no equal to 0. So Vx is 0. This is 0. I gave you the full equation first so that you can trace it through. So R Thevenin, I'm gonna erase all of this. If you remember, what did we do for R Thevenin when we had a dependent source? Very simple stuff, right? You cut load, same thing. Short this because it's a voltage source, and then you add a test, right? We add a test. Let's say V test. And remember, the current is I test is this way. I test is going this way. Okay, so let's do it here so that we can see the graph as well. So what do you have here? You have, if we go this way, negative V test, just a KVL, right? Negative V test plus 4 times I test, right? Minus Vx. And then what happens here? This is shorted, right? So there is no, again, there is no voltage here at all. Because there is nothing here. This is ground. This is ground. Nothing. This is all ground now. There is no voltage at all. So minus Vx equal to 0. I'm going this way. So from here, you can see that V test is equal to 4I test minus Vx. Okay, we need to find the relation now with Vx and I test or V test. So what do we know about here? We know that 2Vx is equal to what? Negative I test, right? So from here, we know Vx is equal to negative I test over 2. So we plug back in and then we solve. That's it, basically. And then you solve for V test divided by I test. That is simply it. Hopefully this makes sense. Okay. Next question. The variable load RL is adjusted for the maximum power transfer to RL. Find RL. Okay. Okay. What is this question? The variable load RL is adjusted for maximum power transfer. Oh, so this is the maximum power transfer formula. Oh, this one I'm gonna skip because all you need to do is basically plug in the formula that we have and you will easily get to that. I don't remember the formula right now, but we had the derivation and the proof for the formula. And this one is asking you to basically get the Bmax, which is the formula that we had. I mean, in the solution, it's V Thevenin here, squared divided by 4 R Thevenin. We derived that as well. And so you have to figure out what is V Thevenin, you have to figure out what is R Thevenin, and that's it. It's gonna be the same way. We have done it before. But okay, let me look at. I think that's yeah. I mean, it's the same idea. You just for the R Thevenin, you will short this. You will add your test here, and move on with this and figure it out to figure out RL. RL is R Thevenin, by the way. If you didn't know that, because this is the load, right? So we're gonna cut the load here and figure out the same stuff. V Thevenin. Okay, let's go with it actually. What is V Thevenin? V Thevenin here is the voltage across this. So you cut this, you find the voltage across here. Okay. If this is open, this is shorted, right? This is open, this is okay. So the voltage here is 2 volt from here to here. Okay. And so Ix is 0, right? Ix is equal to 0. Yeah, because it's open, right? Okay. So if Ix is 0, this is nothing. So yeah, if this is nothing, that means there's no current here. That means V Thevenin is just the 2 volt. Let me restate this. This current is 0 because it's open here. Nothing. If this is 0, this is 0. That means this is also nothing here. So, and this is also open. So there is no current, nothing. The only voltage that you have across all of this is just the 2 volt. Hopefully that makes sense. So that's your V Thevenin. R Thevenin, you're gonna apply the test here. You're gonna short this V test and figure out I test. R Thevenin is V test divided by I test, correct? And so V test over I test. Okay. So what is V test? The voltage across here. This is back in. So the voltage across here is the voltage across. This is back. So it could be the voltage across the 4 and the 2, right? Okay. So what you're gonna do is if this is Ix, okay, I test Ix is equal to I test, right? Because both of them are equal to each other. It's the same current flowing through. Okay. And so if this is if this is, let's say this is Ix and this is 3Ix, so this one here is going as 4Ix. Okay. So V test is equal to 4I test times 2, 4Ix times 2 plus Ix times 4. So 8, what is this? 8, 12 Ix, which is I test. is equal to V test. We want to divide them, V test divided by I test. So we divide on both sides, I test. We cancel them out. This is R Thevenin is equal to 12. Yeah, and then you just plug them here. That's it. Hopefully that makes sense. Okay, there is 2 more problems, I think. 3 more problems. Oh my god. Okay, this exam is long, but it's not very difficult, I think. This one is very simple. This one, there's no current here. I'm gonna be quick, okay? There's no current here, which means this is short. So you have a voltage here. This is your V plus. Okay, V plus is from here. I guess V plus is plus here minus V plus. Okay, so you can do some sort of small KVLs. So -2 plus 3KI, 3KI plus 1KI plus 6 volt is equal to 0. So you have 4KI, this plus this is 4, equal to -4, I is -1 amp. Okay, so this one, let's do a small KVL here. So -2 plus 3K, wait, is this correct? -1 milliamp, sorry. Let's keep the units correct. -2 plus 3K times -1 milliamp plus V plus is equal to 0. So what is this? -2 minus 3 plus V plus is equal to 0. So V plus is equal to 5 volt. So if this is 5 volt, this is also 5 volt. Again, there's no current going in here. So this is short. The voltage at the V minus is equal to V plus, which is equal to 5 volt. So we know that our current here is the same current going here. So 0 minus V minus divided by 5K is equal to the same current as V minus minus V out divided by 1K. V minus is 5. So -5 divided by 5K is equal to 5 minus V out divided by 1K. If we multiply this here, so -5K divided by 5K is equal to 5 minus V out. This cancels out to be -1 equal to 5 minus V out. So V out is equal to 4 volt. Is this correct? No. Wait. What did I do wrong? Oh, yeah, sorry. -1 move to the other side, and this move to the other side is 6 volt. V out is equal to 6 volt. Sorry. Again, it's midnight, so expect some mistakes. Sorry about that. Okay, now it's asking for I out. Well, we know this current. We can figure out this current, right? It's 5 minus I out, V out, which is 6, divided by 1K, which is -1 over 1K, which is -1 milliamp, correct? So the current here is -1 milliamp. We can also figure out the current here, which is going to be V out minus 0 divided by 6K. What is V out? 6 volt. So 6 divided by minus 0 divided by 6K is 1 milliamp. So if this is 1 milliamp and this is -1 milliamp, so this I think has to be, wait, this is going in, this is going in. So -1 plus IO equal to 1 milliamp. So IO is 2 milliamps. Just a small KCL here. That's it. That's the question. Very simple, very easy, right? Okay, moving on to the next question. Hopefully I didn't lose any of you. Well, again, no current going in, so this is short, right? V plus is equal to V minus. What is V plus? Simple, 2 volt. What is V minus? Simple, 2 volt as well. We got this, we got that. Cool. Now we know this is a current. We know this is a current. They're gonna add up. These two currents are gonna add up to this current. We did a very similar question in the class. So what is the first current? Let's call it I1. And let's call this one I2. What is I1? I1 is simply 9 minus 2 volt divided by 7. And then what is I2? I2 is simply 7 minus 2 divided by 5. So this is 9 minus 2 is 7. 7 divided by 7 is 1 amp. 7 minus 2 is 5. 5 divided by 5 is another 1 amp. So you know that the total current here is 2 amps. So there is a 2 amps going through here. Okay, so 2 minus V out divided by 6 is 2 amp. So multiply 2 minus V out is equal to 12. Move this, actually, move this here. So 10. So V out is negative 10 volt. Make sense? Hopefully it makes sense. I went a little too quick. Hopefully this makes sense. Okay, so we know this current is 2 amps. Now we're trying to find IO. We try and let's figure out this one. We know I out is negative 10. So it's negative 10 minus 0 divided by 10 is this current here, I3. I3. So that means it's negative 1. So let's do a small KCL here. 2 amps going in plus I out going in is equal to negative 1. So what is it now? Move this to the other side. So I out. Sorry, this is also amp. So negative 3 amps. Negative 3 amps. Does that make sense? Hopefully it makes sense. I don't know. I hate this because there's no live reaction, but hopefully this is simple enough that it makes sense. Okay, this one is very similar to the one we did in 22. So please pay extra attention to this one. It's very simple, but if you get the trick, if you didn't get the trick, it's gonna be a little bit hard. Okay, let's say this is called V1. Hear me out, okay? Because some people didn't understand it in the last one. This one is V1. What does that mean? It means the voltage across, let's call it VL. The resistor here is VL. So this is VL. So what is V plus? V plus is 3 volt is the sum of the voltage here and the voltage here, right? Which is 3 volt plus VL. Simple, right? Okay, what is V minus? V minus is equal to V plus. We know that. Okay, what is V minus? Is the voltage from here to here and the voltage from here to here. So it's the voltage across the 3 ohms plus VL. Okay, let's put these two in the same in here. So 3 volt plus VL is equal to V3. This is the voltage across the 3 ohms plus VL. VL will cancel from both sides, for V3 ohms is equal to 3 volt. What does that mean? It means the voltage across the 3 ohm resistor is equal to 3 volt. Okay? So let's put our currents now. Let's say we have a current here. We know there is no current here. So this is the same current going here, right? Let's call it I1. It's the same current going here. We know there is no current here. So this current has to go through here. Okay, so what is this current gonna be? What is I1? I1 is the voltage here, which is V minus this voltage divided by the 3. But we know that it's 3 volt. That's 3 volt. So the current is V equal IR. So it's V 3 divided by 3, which is 1 amp. Correct? So you know this is 1 amp. We can trace it back because we know current here is 0 because it's an ideal op amp. So if we trace it back, this is V out. So V out minus, actually, let's not trace it back. Never mind. Let's trace it back. V1 minus V minus divided by 3 is equal to 1 amp. Which means V out minus V minus is equal to 3. Okay, let's keep it like that. We'll come back to it again. Okay. What happens after here? What is our next step? Just think about it. So we know this one is here. We know this one here. Okay, what do we think? Wait, let me think. Okay, very similar again to the 22 exam. The voltage here is the voltage across this plus VL. So V out is equal to the voltage across this 3 ohm plus VL. Or from the other side, it is the voltage, V out is this voltage across this 3, another 3 ohms, plus the voltage of the other 3 ohms plus VL. So if we cancel this out, the voltage across this is the same as the voltage across this plus the voltage across this. You would say, how? That doesn't make sense, right? Well, you'll understand how. We'll figure it out together. Wait. Um, let me think. Actually, maybe not. Maybe let's not do it this way. Okay, okay, never mind, never mind. Okay, let's think, let's think. Is this the last question? Yeah. Okay, okay. So we figured out the current. What do we do now? Wait, wait. Mm, wait, wait, wait. Let me think. Let me stop and I'll come back. Okay, okay. I figured it out. Sorry. So we know that the voltage, we figured out that this is 1 amps, right? That means the voltage across here is also 3 volt, right? And the voltage across here is 3 volt. Let me change the color so that we know. So plus minus 3 volt, and this is plus minus 3 volt. So we can do some sort of a KVL going through here. Because now V out is, let's say, or not V out, let's call it, this is V out, sure. But let's call this another voltage here. Let's call it Vx. We can do a KVL going this way, and this way, right? So negative 3 volt minus 3 volt plus Vx, right, is equal to 0. What is Vx? Vx is 6 volt, right? Okay. So we know now that the voltage across here is 6 volt. So V out is what? 6 volt plus VL. Okay, good. Okay, so we know this now. We know this. Now we need to figure out the current across here. So the current across here is going to be the sum of this, or like a KCL here. But we don't know this current either, right? But we know Vx. Simple, right? We know Vx is 6. Okay, so using V equal IR, the current is V divided by R. V is 6 divided by R, which is 3. So the current is 2 amps. So the current here is 2 amps. So if this is I out, let's figure out I out. I out is going to be, let's do a KCL. I out is going in. This one is going out. This one is going out. So 1 amp plus 2 amps. So I out is 3 amps. Okay. Okay, we figured out this current now. Okay, so let's do another KCL here. So we know this current is 0 amps. It's going in here. So we know what is going in. 1 amp. What is also going in? 2 amps. What is I out? Here. 3 amps. Oh, I called this IO. Sorry, I'm talking about this current, huh? This one is this one here. They called the same thing. I called them IO and I didn't notice this is also IO. Sorry about this mistake. But this is 2 amps, I know. And I know this one is also 1 amp. And this one, those two are going into the node. This one is going outside of the node. So you add both of them and you get 3 amps going out. So what is the question asking? Find IO through this, find IO through the resistor RL. So we figured out the resistor now as 3 amps. Simple enough, right? Second part is saying if the value of the resistor RL changed from 6 to 12, would IO change? No. Did we even use the value of 6 here? We didn't even use that resistor. All we did was figured out the current going in here, the current going in here, and we added them together, and that's how we get it. This question is a little tricky. So review it, go back in recording and watch it again, step by step, see what happened. Quick review. I'll try to do a quick review again of what happened. This is the same voltage here. So the voltage here plus here should be the same thing as this plus this. These two are in common, so you cancel them out. So the voltage here, which is 3, should equal to the voltage here. So you find the current here as 1 amp. You trace it back, there's no current here, so you know the current here is also 1 amp. If this is 1 amp, okay, now you can figure out the voltage here, which is 3 volt, and the voltage here, which is 3 volt as well. 3 volt. However you want to put the sign. But this is 3 volt. Let's put it this way. 3 volt, and this is plus here. 3 volt. And so you can do a KVL here. You can trace this here. And you will figure out your voltage here. You ended up knowing that this voltage is 6 volt. So you know this is 6 volt, you know now the current. You get the current to be 2 amps. Now you add them and you figure out your I out. You add this and the current here, which is the 1 amp. So you get your I out. That's it. Hopefully this makes sense. Again, I'll try my best for the second one, for the last one, but hope this makes sense. Hope this gives you an intuition about the exam. Good luck with the exam and let me know how you guys do, okay? And again, as always, if you have any questions, email me your questions and hopefully I can get back to you as soon as possible. See you guys and good luck with the exam. Bye.